Hello students, welcome to my channel The Report Card, and I'm again back with another video on chemistry. And in this video we will be talking about how metals combine with non-metals. Okay, basically the reactivity of any element, it depends upon its position in the periodic table, or we can say its electronic configuration. Okay, so the electronic configuration of any element will tell you what its reactivity is going to be, how is it going to behave, whether it will behave like a metal or will it behave like a non-metal. Okay, so what exactly is electronic configuration? Now you all must have studied it in grade 9th, that it is the distribution of electrons in the various energy shells, okay, in an atom. That is what is electronic configuration. For example, if sodium, let us just take sodium. Now sodium's atomic number is what? It is 11. Okay, it is 11. It means that sodium has got 11 proteins. When I am talking about the atomic number, I am actually referring to the number of protons. Okay, but as we know that in a neutral atom, the number of protons and the number of electrons are equal, they are same. Therefore, sodium will have 11 protons as well as 11 electrons. Okay, so now when I am talking about the electronic configuration, I am talking about the distribution of electrons. And when I am talking about the distribution of electrons, we have to follow the Bohr-Bury scheme. Okay, so what is according to this, the first shell of any element will have how many electrons? 2 electrons. Okay, so sodium will also have 2 electrons in the first shell. Now how many electrons are left? There are 9 electrons which are left. Okay, now these 9 electrons have to be distributed again. So the second shell will always have 8 electrons. It cannot accommodate more than 8 electrons. Okay, so we have 8 electrons in the second shell. Now how many electrons are left? 1 electron. Now the 1 electron which is left, it will go and place itself in the third shell. Okay, so this way the electrons are arranged in K, L, M or 1, 2, 3, whichever way you want to name the shell, right? So this is how it is arranged. Well, now the last shell of any atom is known as the valence shell, and the electron which is there in it is known as valence electron. Okay, this is something which you have studied it in grade 9, right? So valence shell and valence electron. So it is the last shell of any atom which is a valence shell, and the last electron is known as valence electron. Okay? Now this valence shell or valence electron is very important. Why is it important? Because the electrons in the valence shell will only combine. Okay, they will only move in or out. See, suppose if an element if an electron has to get into an atom, it will always come and rest in the valence shell only, because that's the first shell. I mean, when you are coming from outside, you definitely enter into the first room of any a flat or an apartment, right? So the moment you are entering in, you step into the drawing room. So in the same way, if an electron is coming, it will always enter into the valence shell, and when you have to go out of your apartment, definitely you will move out of the same room only, right? You will first go to the drawing room, and from there you will move out of the main exit. So in the same way, if the electron has to go, it will go out of the valence shell. So that means the valence shell is basically capable of the exchange in movement of electron in and out of an atom, right? And this decides the combining capacity of any element also. So that is the importance of valence shell and valence electron. Okay, so now I think it is very clear to you. Fair. Now I am coming on to two rules, okay, of this topic only. So there are two rules. One is known as the duplet rule and other is known as the octet rule. Okay, these two rules are very important. Okay, now what exactly is duplet rule? Duplet rule states that if any element or any atom has only one shell, okay, if any element or any atom has only one shell, then for atom to be stable, that one shell should have at least two electrons. Okay, like for example, if I say there is an element X, okay, now this is the nucleus of the element and this is the first shell of that element. Okay, now this first shell will be named as K. Okay, so now if this first shell has just one electron, this atom will be very unstable, right? It should have how many electrons? Two electrons, then only it will become stable, right? So whenever and I'm talking about only one shell, and it cannot have more than two electrons also, right? According to the Bohr-Bari scheme, you cannot have more than two electrons in the first shell of any atom, and two electrons are necessary for that particular atom to become stable. Okay, and what does this octet rule say? Octet rule states that if any atom has more than one shell, okay, then in that case that atom should have at least 8 electrons to be stable. Okay, so for example, let us just take an element Y. This is the nucleus of the element. Okay, this is the nucleus, and then this is the first shell and this is the second shell. Okay, so the first shell, suppose it has got 2 electrons, right? Now the second shell, if it has got 1, 2, 3, 4 or 5 right electrons, still it is unstable. It actually needs how many electrons? 8 electrons, 6, 7 and 8. So now if it has got 8 electrons, then it is stable. So this shell I am naming it as K and this is L. Okay, so this is what the octet and duplet rule is. Okay, now what happens when an element does not have the required number of electrons in the valence shell to be stable? Okay, like for example, if I say that this element has got only one electron, okay, it has got only one electron, so definitely like every element or like everything in this entire universe which try to attain stability, okay, so in the same way this atom will also try to attain stability. And to attain stability, either it will have to lose this electron and the entire shell will be destroyed, so it would be like na rahega baas na bajegi bansuri, so there would be nothing, तो इलेक्ट्रॉन्स की कोई जरूरत नहीं है. बट व्हाट इफ जो है, और दूसरा तरीका क्या है? दूसरा तरीका है कि आप इलेक्ट्रॉन्स को अट्रैक्ट करिए, आप कोई इलेक्ट्रॉन लीजिए और इसके अंदर आप इसको जो है स्थापित कर दीजिए, या इफ द एलिमेंट शुड अट्रैक्ट वन इलेक्ट्रॉन एंड टेक इट. Okay, so that way it will become stable. So the same applies here also. So suppose if there are 3 electrons less in this particular shell, then the element or the atom will be very unstable. So in this case, the atom or the element will try to either gain electron or to lose all the left electrons. So if there are electrons, तो atom या तो lose कर दे electrons को, या फिर atom electrons को gain करे. So these are the only two ways by which the atom can become stable. Okay, so what are the two ways by which the atom can become stable? Either lose electron, okay, either it will lose electron, or it might gain electron. ठीक है? So these are the only two ways by which an atom can actually become stable according to duplet and the octet rule. Okay, so is it clear the duplet and the octet rule and how the atom can attain stability according to this particular rule, right? Now let us see which atoms actually tend to lose electron and which atoms tend to gain electron. Now that is also decided. Okay, let us take an example of sodium. Okay, so when I take an example of sodium, we find that sodium, this is the atom of sodium. First shell will have 2 electrons. Second shell will have 8 electrons, 3, 4, 5, 6, 7 and 8. Okay, and the third shell in sodium has just got 1 electron. So actually sodium requires how many electrons in this particular shell? It requires 7 electrons. Okay, now gaining 7 electron is really very tough. Okay, it is something like you want to buy this item, you want to buy this duster and this cost 100 rupees and you have got only 1 rupee with you. So you will have to ask for 99 rupees from someone, and definitely it's not going to be an easy task. Okay, people might not give you 99 rupees. They will say, why you are just carrying 1 rupee and you want to buy a duster worth 100 rupees? That's not done. So the same happens with sodium. So what to do? The thing now what to do is, like if I've got just 1 rupee, I will say okay, leave it. I don't want 99 rupees. I'll give this 1 rupee to someone and I'll get rid of my intention of buying this duster, because if I am having that 1 rupee, I'll keep on thinking about this duster. But if I give this 1 rupee to someone, then I will have not a penny left and definitely I'll forget about this duster. Okay, so the same thing happens with sodium. The sodium, it tends to lose this electron because losing 1 electron is very easy, right? So whenever something loses electron, so it is always going to gain what? A positive charge. Okay, because electrons are negatively charged. So when you are losing a negative charge, then definitely you gain 1 positive charge. Okay, so now this is what the sodium does. So any element which tend to lose electrons, they are termed as electropositive. Okay, they are termed as electropositive elements. Clear? So this is something very important. Now let us take another example. You can take an example of magnesium. Okay, just take an example of magnesium. So magnesium has got total 12 electrons. So similarly over here, if I say magnesium, so in the last shell, magnesium will have 2 electrons. Okay, so again the same problem. Now instead of 7, magnesium requires 6 electrons, and 6 is again a big number. So magnesium also have a tendency to lose electron, because it says okay, 2 electrons I can easily lose. Okay, so this is what magnesium does. And same if you look at aluminium. So aluminium also does the same, because aluminium's atomic number is 13. So its last shell will have 3 electrons, and 3 electrons also it is easy to lose. Okay, but when it comes to 4, 5 electrons, then it's the elements tend to behave in a different way. But elements having 1, 2 or 3 electrons in their outermost shell or their valence shell will tend to lose electrons and are known as electropositive. Okay, they are called as electropositive elements. Okay, so this is something very important. So all the metals, they are electropositive. Okay, remember, every metal is electropositive. This is one of the basic characteristic of a metal, that metals always tend to lose electrons and they are always electropositive. Fine. Well, now let us just take an example of chlorine. Okay, let us take an example of chlorine now. So I am just removing this from here. Now let us take an example of chlorine. Now what happens with chlorine? Chlorine's atomic number is 17. Okay, it is 17. Now 17 means that its outermost shell will have 1, 2, 3, 4, 5, 6 and 7 electron. Okay, and of course 2, 8 and 7 would be the electronic configuration. Okay, 2, 8 and 7 is the electronic configuration. So its outermost shell will have 7 electrons. Now definitely it requires only 1 electron. Okay, so 1 electron can easily be gained. If you have 99 rupees, you need just 1 rupee to buy this duster. Definitely you will easily get 1 rupee. You can ask anyone, okay, I'm just having 99 rupees, I'm having 99 rupees, I just want 1 rupee. So anyone can give, okay, you take this and you can buy this duster. Okay, so what happens? These, I have written magnesium over here, it should be chlorine. Now what will happen? The chlorine will tend to gain electron. Okay, it will gain electron from outside and thus it will, complete its octet. It will complete its octet and it will become stable. So besides chlorine, there are other elements also. For example, sulfur is another element which can gain electron. Okay, so normally it is seen that any element which has got around 6, 7 or 8 electron, or even 5, 6, 7, 8 electrons in their outermost shell, in their valence shell, tend to gain electrons. Okay, they tend to gain electron to complete their octet. Okay, and they are called as electronegative. Okay, why electronegative? Because whenever an electron is added, so if an electron is added to chlorine, it will gain a negative charge. Okay, and it will become chlorine, right? So all the non-metals are electronegative. Okay, so we have two types of elements now, electropositive and electronegative. Right, so when we are talking about metals, they are electropositive. When we are talking about non-metals, they are electronegative. Okay, so now we can make out as to how they are going to combine. For example, suppose I am a person A and again there is a friend of mine B. Okay, I am having I am having 99 rupees and B is having just 1 rupee, and there is this duster worth 100 rupees. Now I am going to even I want this duster, and the other person, my friend B, also wants this duster. The only difference is the money that we are carrying, right? So now when I go and we both meet each other, me and my friend, then mutually what we can decide, I say, okay, dear B, I just want this duster and I've got 99 rupees with me. If you please give me 1 rupee, that would be very great. It will be very helpful. So B will say, okay, giving 1 rupee is very easy for me. So B will give me 1 rupee because B is electropositive. It has a tendency to donate. Why? Because it has got less money. Simple. And I have a tendency to take that money. Right? So B will give me that money and I will take that money. Okay. So let us just talk in terms of electron. So instead of money, B has 1 electron and I have got around 99 electrons. So what will happen? B will give me that one electron and I will complete my 100. B भी अच्छा है क्योंकि B के वो शेडी चला गया. I mean he just doesn't need money now. He is stable as such because he was actually in pain with that one rupee or one electron. तो जैसे ही B ने मेरे को वो इलेक्ट्रॉन दिया तो I gain a negative charge, B gain a positive charge. Okay? या B ने जैसे ही मुझे पैसे दिए I am satisfied, I can buy this duster. तो definitely जब B ने मेरी मदद करी तो a bond is formed between us, isn't it? So I cannot forget B because he helped me. तो अब हम दोनों ने एक दूसरे को हेल्प करा किस चीज के लिए? To become stable. तो हम दोनों के बीच में एक बॉन्ड बन जाएगा, राइट? एक बॉन्ड बन जाएगा और यही बॉन्ड मेटल और नॉन मेटल के बीच में बनता है. तो जब भी एक मेटल और एक नॉन मेटल आपस में मिलते हैं तो ये दोनों एक दूसरे को क्या करते हैं? सेटिस्फाई करने की कोशिश करते हैं. मींस दे वांट टू कंप्लीट देयर ऑक्टेट. तो ऑक्टेट को कंप्लीट करने के लिए नॉन मेटल को इलेक्ट्रॉन्स देते हैं और मेटल्स जो है उन इलेक्ट्रॉन्स को आपके आई अगेन वांट टू रिपीट, जो मेटल्स है वो नॉन मेटल्स को इलेक्ट्रॉन देते हैं और फिर जब दोनों में चार्जेस डेवलप हो जाते हैं, ऑपोजिट चार्जेस, फिर दोनों कंबाइन हो जाते हैं. एंड दैट कॉम्बिनेशन इज थ्रू अ बॉन्ड नोन एज इलेक्ट्रोवेलेंट बॉन्ड. Okay, so today's video I'm just keeping it here, stopping it here, because what will happen now, the video will become very long and it will take a lot of time to get uploaded. So in the next video I'm going to talk about these electrovalent bonds and how are these formed and how do you represent the formation of these bonds through an electron dot structure. Okay, till then take care, goodbye.